Welcome to the class. All those who are on time, I'm grateful to you. And those who are watching the recording, I suggest that you skip the first minute or two because I will wait for some more people to join. We'll wait for a minute or two and then we will start this class. And as you can see, Abhinav Kumar, good afternoon. And as you can see that there are things ready to use. Today's content will cover 1.1 NCERT 1.1 to 1.5, and it includes charging by induction, charging by conduction, charging by touching. Akshat, Abhinav, good afternoon. So we will do the same. We will not just study the theory. Shashank, good afternoon. So initially I will respond to your good afternoon, but after a minute or so, I will stop responding to good afternoons because that disturbs the class. Gauri Priya, good afternoon. So today's class is from 1.1 to 1.5 of NCERT. As I have told you earlier, these classes are NCERT based, and so all questions from NCERT will be done in the class. Today's class is 1.1 to 1.5 of NCERT, which includes charging by induction, and I have certain things ready. I will bring it to you. At that time, do remind me because yesterday I did that mistake. I forgot to enlarge the video part when activity was going on. Today I have to increase that size of video when I'm showing you the activity. So kindly remind me at that time, sir, to increase the size of the video. So I will take as many doubts as I can. I like when you send those chat messages. The class will be for around 40 minutes, 40 to 45 minutes. So don't worry, I won't be boring you for long. And we'll keep it activity based, we'll keep it discussion based. So Anha, Dismita, Anshre, everybody welcome. Now I will not be able to respond to good afternoons once I start. So quickly I will go through this thing, that where is the course that we are following. Course is at anytimeteacher.com, and at anytimeteacher.com you go to academic courses for MCS. There you have 12th physics, pick up electrostatics and click on take this course, which is next to that green button, which is free. In green it is written free. After that you have a button which has take this course. Click on that course. There are self-assessing quizzes on every page which you can try, and these are the details to reach out to me. These details are posted in the first 2 pages of the course. Here I am just showing them to you, but you can use them from the course. All these details are written there. The animations that we are using to visualize electric field, and we will be using more animations. To find them, you Google search for PHET, P-H-E-T, PHET, and the first search result will itself take you to the right link. The site is actually phet.colorado.edu. These are from Colorado University. From simulations, top, there is a menu simulations, pick up physics, and then pick up electricity, magnets, and circuits, etc. There are 25 animations there. We are using 3 of them. So few activities that we have done. Already we have done. Few activities we have done using balloons. But then yesterday I told you which balloon. That is the Gyan part. Which balloon? This balloon is the one which you would have seen that your school uses at the time of Independence Day and 26th January. These are little bit, say, rubbery kind of things. And these are light balloons which we use at the time of Holi, water balloons. You saw it yesterday, and in case you want to see it again, you can ask me to do it. I have posted one video in the course. If you simply rub this balloon with your hair and you put it anywhere, it stays there. This one will not. You try doing this thing, it will fall. It will not be able to hold on there. These balloons, they are very good. So one of the activities that we have done is we rub the balloon on the head, it sticks to the wall. Then two balloons that you can see in the video on your left, two balloons rubbed on the head, placed to each other, they repel each other. Then a balloon kept on a table, and if you have a straw and you rub that straw with a tissue paper, you can make that balloon move. We have done that. And using straw, and we charged it by rubbing it with a tissue paper, we saw that if you put it on, I placed it on a lens yesterday, it rotates. Without touching, it rotates. If you bring the hand near to it, it rotates. And it does beautifully. In this weather, it does beautifully. In the month of July, etc., you will see it doesn't. So there is a part of the gyan, of the knowledge, which is not written in the books. Not written in the books, but that phenomena is stronger than what is written in the books. For example, these two balloons which are hanging here, when I rubbed them with my head and released them, they repelled. Yes, they repelled. But after that, I showed you something which you can see in the first intro class, and I'll be using it again a class or two later when I come to Coulomb's force. That when I brought my hand near to one of those balloons, the effect was much, much stronger. Likewise, with the straw, we saw that when we rubbed this straw with a tissue paper and kept it on a lens I kept it because there is a freedom to rotate. I should not be restricting its movement. So I kept it on a lens, because convex lens, because it has a surface like this. So when you place it over it, it is free to rotate. And it rotated. But then another one, which was a stronger effect, that when I placed that lens over this block of wood, the straw always turned the way you see magnetic compass needle turning. It turned and it became parallel to this surface and it stuck to that surface. And that phenomena was quite strong to be ignored. And these are not the things which are mentioned in the books. So what we did, we picked up a much bigger piece of wood, quite a big piece, and we balanced it over the lens. And then we charged this straw, and then we charged it. Yes, I will increase the size of the screen. Ansh, when I do the activities, I will increase the size of the screen. I'll remember that. Then we charged this straw by rubbing it with a tissue paper. And the whole of this big rod, it rotated, it moved when we brought this small straw near to it. These effects are that much large. We have seen these kind of things, and with the time as we need it, we will keep doing these activities. Now, if you feel that why is it that we are making the charge stay, touch it with a straw, why don't we allow it to flow? We will come to that flow of charge in second chapter, which is current electricity. This first chapter, electrostatics, the charge once given to a body, it stays there, static. And this chapter is worth 10% of your class 12th board exams. significantly important chapter is statics. When charge is given to a body and it stays to that, it is not in a consistent flowing state, which is your next chapter, which is another 10% of the class 12th physics syllabus. Current electricity is next chapter, when you will have a smooth continuous flow of charge. We will come to that chapter. That would be chapter number 2. That will come after some time. Right now we are concentrating only on static electricity. So out of the things that we have used so far, you can classify them into 2: conductors, but conductors are of varying degrees. Good conductors, better conductors, even better conductors. And then there are certain things which are not in your syllabus right now, but a slight mention is there in your syllabus. That is superconductors. But then when you go towards the bad side of a conductor, say conductor, not so good conductor, and then you come to a state where things don't conduct, and you start calling them insulators. Now, insulators also have this kind of classification, say grade. Insulator, good insulator, very good insulator, bad insulator. You have insulators also, you have a lot of category. And we will come to that when we are studying capacitors and we are talking of this dielectric breakdown, etc. That these insulators, they start conducting when you apply large voltage over it. And large doesn't mean very, very large. Large doesn't mean that those huge pillars, those poles that you see 33,000 volt kind, not that. Within the lab, you can see that these insulators, they conduct. Now, at what voltage do they start conducting? That depends on which material you are talking about. So one place where I have been able to show it to you was this, that there is a balloon and there is a balloon, and balloon, they are different from each other. Okay? But few questions I am leaving it with you so that you get a chance to think over it. Instead of the straw, if I take a metal pipe and I hold it the way I am holding a straw, will it work? You think over it, and someday at some forum we will talk about it, that instead of this straw, if I use a metal pipe and hold it the way I am holding this straw, no handles, no wooden handles, no plastic handles, I hold it the way I am holding it like this, will it work? Second, if instead of balloon, I use a metal ball. Now, I have made the 2 metal balls and I'll show it to you. I'll bring it near to the camera and I'll increase the size of the video. If instead of balloon, I use a metal ball, what will be the effect? Say, what is the difference? Will the charge flow? Will the charge hold? All those type of things. Are they, say, what will be the situation? Say no, Akatsuki. I'm not able to read this name, Akatsuki. I think because of earthing. So there are few words that are coming up now, and actually they are part of your syllabus. Those initial 1.2, 1.3 introductory, which many of you don't even read. There are 2 categories that you will see, conductors, and I said there is a grade, whole range of grade in conductors. And there are insulators and whole range of grade in insulators. And this earthing will also come, and it will come right now into play. When I do an activity, it will come into play because before the class, I was playing with these balls. So these balls might be having some kind of charge already on it. And what I do to these balls, to make sure that there is no residual charges from my previous activities. Say before the class I was doing something, so might be these balls have some kind of charge already there. So we will talk about it, and today's class is how do you charge an object, and then we will go back to what we were doing yesterday, that what is this happening, that 2 things are interacting, what is there around it that it behaves like this, and the forces are like this. We will come back to that topic, but today the 1.4, 1.5, that part of NCERT, that how do you charge a body? And once you charge, then all those type of things, and why it is behaving, why there is a force, all these type of things. So quickly, what we have seen so far, yesterday, day before, when you rub, for example, straw and tissue paper, when you rub, there is a transfer of something from one body to other. We saw it historically that how our forefathers would have been fascinated with this kind of thing, that the phenomena that you see, what we have also done those activities, how fascinated they would have been, and how would they be reasoning out what is happening, why it is happening, what is the cause. And they could have seen one thing, that when you rub, something get transferred from one body to another, something gets transferred. And so they named it charge, that charged body. Now we understand, but it could have been in any word. So now when you say the fellow is very much charged, so you know that this fellow's blood pressure has gone up. And I say he's a very charged up speaker. So he's talking with a lot of passion. You say he's charged up. So they said all these things when they behave the way we have seen in various activities, said it has been charged up. And from all the possible combinations which we saw in NCERT 1.2, there were a lot of, and I showed you that NCERT, and if you have your PDF, you can download it free of cost from NCERT website. There are various combinations given there, and some which you can't understand, but most of the things which you can understand, like glass rod, silk, pith ball you might not be able to understand, wool, uh, ebonite rod you might not be able to understand. But then most of the things you can understand. But then you understand straw, you understand tissue paper, you understand balloon, you understand metal foil, which is there in the household. From all these combinations, our forefathers, they could make it out that there are two types of charges. And we saw yesterday they could have been named red type of charge and blue type of charge, or A charge, B charge. But they named it positive and negative because of cancellation. That we put together two types of those charges, put together, they cancelled out. So they named them, put them in two categories of positive and negative. The electron, which was discovered much later, happened to be from that party which is negative. It's coincidence. And we try to ball is something that you Google search. What is that material pith ball? Because earlier people used to find it one of the most common thing to work on. So Google search it, that what is it? What is that material? You understand glass. You think you understand glass. That glass rod. Do you think glass rod is so common? Wool we understand, silk we understand, but glass rod things were not very common. This is the styrofoam ball, the thermocol ball, styrofoam ball. These were not very common at that time, but then now they are very, very common. Sir, can you turn off desktop notifications? Are they visible to you? Man himself added. Because right now the screen, yeah, that tuk is coming, and that I will solve out the problem. I have muted the a lot of notifications. Now, sir, that sound will not disturb you. Okay, so we will come to now this charging by conduction, charging by induction, and now I will increase the size of the video and I'll bring these balls near, and then we will discuss whatever is going on. Okay, let me increase the size of this video now. Those who are technologically sound, you will realize what I am doing now. Okay, just to, okay. So now I will bring it closer and I will make sure that you see that there is a gap between these two. I hope you are able to see that there is a gap between these two metal balls. If you find it funny, see, metal balls in these times of closure, when shops are not opened except the doodh wala shop and biscuit namkeen wala shop, arranging for a metal ball is not easy. But then covering up a table tennis ball with metal foils which are there in your household, common metal foils, something like this. common metal foils. That makes it a metal ball. Now, are you able to see the gap between the two? Are you able to see the gap between the two? Should be. I can turn it aside a little bit so that it is even better. Right. Okay. Now let me rub it with a tissue paper and you see what happens. I am not going to touch anything. I'll just bring it nearer to these balls, but you see it carefully. I wish I could have shown it to you. I wish I could have shown it to you with slow motion, but then kindly observe. Let me take this tissue paper. Did you see something that happened? Still it is happening. Still it is happening. And now I'll show you. I'll touch now. This time I will touch. And now you see what happens. This time I will touch. You can do these activities yourself, by the way. So far I have not touched them, but now I'm going to touch them. Did you see what happened? I can. Acha, Himanshu sahab. I can make this ball dance even more. See, do you see that? Because this ball has some weight, but then I am able to keep it pulled to me. Do you see this? This is a lighter ball. Electrostatics. Nahi, Sarthak, no spark. Spark will come if I use this capacitor. If I use this capacitor, this is a significantly large capacitor which is there in your fan. Then you will see a spark. But even then you will see just a small spark. It is not bhadak, say spark will come, but chatak kind of spark will come. That kind of thing will happen. So what all we saw, what all we have seen, now we are going to discuss that part. We will be discussing this part now. So little bit of work and then we will do some basic numericals which are given in NCERT. We will do those numericals on these charges. So get ready for some kind of explanation and have some, sir, can you repeat without touching wala? Without touching wala, okay. Anushka Goyal, for your sake, yes. Okay, I have to make sure that these balls, they do not have any charge. So what I'm doing is I am I'm not putting on shoes, I'm putting on slippers. So I'm removing those slippers and now I'm touching these balls with my hand so that whatever static charge is there, it goes to the earth. That is called earthing, that you connect something directly to the earth. Now, my body is a conducting body. That's another topic. That is it, spark will come when current hoga, not charge. Not really. Even with charge, the spark will come. So, whether my body conducts through the blood or through the skin, that is a different topic. But my body is a conducting body. So what I'm doing is I have touched these balls with my hand and I have removed the slippers. That way I have ensured that there is no static charge, leftover charge on these balls. And now on demand from Anushka Goyal, I'm doing it again without touching part. Without touching part, you see that. Could you see it? Now we are going to discuss it. We are going to discuss it now. And then you will start understanding it and I will recommend Because these are very easily doable activities, I will recommend that you do these activities. Try to do them. You have a lot of time now. Try to do them yourself. And say, let me change the screen size once again. Reduce my size and bring these things in the front. Okay, keep your paper pencil ready because you have to think along with me, followed with little bit of numericals also that we will be doing today. Okay, so case number 1, let me find out where is this pen gone. Just a second, give me just a second. There will be a disturbance, small disturbance. Okay, now it is working. So you have one metal ball, you have another metal ball, and these metal balls are say here I'm drawing a stand because it will look more like NCERT now, but I was hanging it with a thread. Okay, but here just for the sake of that it looks similar to NCERT, I'm keeping it like this. And here we bring near to it something which is charged. Now, whenever you see in NCERT that a charged rod is brought near to a metal ball, you should not be confused. You know what was that charged rod? That was a straw. So I'll write here that is straw rubbed with humble, simple tissue paper. Okay. So now you have a reason to understand what was there in it. Now you start reasoning with me. This positively, let's say positively, let's say, let. I'm not sure still. Let's say this is positively charged. What do you expect this shell to do? If there is only one, what do you expect this to do? What I'll do is I'll draw one more case here. One more. I have enough space. And say this is that metal ball. So this is your metal ball, and say this is positively charged. So what do you expect this metal ball to do? See, because it is a metal conductor, you expect charges to flow in it. If it is metal conductor, then you expect charge to flow on it. Insulators, they won't allow whatever charge, wherever you have placed, it remains there. So what will happen is, overall it is neutral, negative will be attracted this side, positive will go this side, because overall it remains no transfer. Ashwath, there is no transfer of electrons. There is only redistribution of these charges. Dipole moment jaisa kuch hoga. Your word term is not exactly wrong, and I want you people to speak. I want you people to use your mind and give word to your thoughts, because even if it is a wrong answer, that puts you on the track of learning. So continue doing all these kind of things. The word used is induction. This side attracts negative, and so this side is relatively positive, because overall there has been no touching. No touching. So overall, if it was neutral, it remains neutral. Have I been able to clarify this part? This metal ball, if it was neutral, how do I know it was neutral? How do I know this ball was neutral to start with? Neutral. Why don't the electron jump? Jump. Okay, we'll see that when it jumps. Ashwath, remind me of this question. I will answer this question after a few minutes. But first answer this question. How do I know that this ball was neutral? Because I say if this ball is neutral, then minus on one side, plus on one side, it will remain neutral. Positive and negative sides will be creative. That's okay, Devanshu Sinha. But my question is, how do I know that this ball was neutral? If there is small gap, I think they will. Achha, you all people have started answering Devanshu's question. Well, in that case, I will answer this question, which you people have started discussing amongst yourself. Jumping means you have to cross this air. Jumping from here to here means you have to cross this channel, this barrier, this air, which means air must conduct. And air, which is a insulator, if it is conducting, that is called dielectric breakdown of air. It does not happen at very low voltages. It does not happen usually in dry air, but then it happens. It happens. So have I answered that question? Means air has broken down. That's called dielectric breakdown. And in this case, it is a dielectric breakdown of air. Because you, very good. Akat Suki, will you please tell me what is her actual name? Because I don't know anyone with the name of Akatsuki. Gemini Creations, naam bade bade bhaiya badhiya dhoondto. I hope that you tell your parents that these are the names that you like. And the names that they have given, they are not to your liking. Protons and electrons are balanced in a material. Huh? Because you, okay, current kahan se aaya? Current? Where is current? Mudit Goyal, there is no current. Touching it, you will not feel current. Okay. Ashwat says he has understood. Now that answer is correct. Who gave that answer? That I'll have to go through these these comments to okay, Adit. Akatsuki Adit. Okay, Adit. Okay, how do I know that this ball was neutral? Because I did something earlier. I said earthing. I removed my slippers, my chappal. I touched my feet on the ground and then I touched these balls. So I know that this metal ball was a neutral. Is that okay? Earth is taken to be at zero potential because it has infinite capacity. You give it lot of positive charge, doesn't matter. You give it lot of negative charge, doesn't matter. So Earth is taken to be at zero potential. Okay, now when I bring this positive charged rod near to it, this is neutral. So the side nearer to it, it gets a negative charge and the other side is a positively charged. Now this plus and this minus will attract. This one will attract and this plus and this plus will repel. But because these are nearer, so their effect is stronger. Because they are nearer to each other. So this effect of attracting each other is stronger than this effect that they are repelling each other. And so you see that ball moved towards that and I kept that distance safe that when it comes towards me, I'll move away. If I do not want them to touch, I kept that, I was careful enough that when it moves towards me, I move away. Because when I move away, there is no touching. There is no touching. Now, when they touch, suppose this rod touches this ball. In that case, this ball will share these positive charges. Some of these positive charges will come on this ball. Okay, and that will mean that this ball becomes positively charged. It means that. We'll come to that point. We'll come to that point. How can you charge one ball and how can you keep it charged? That we will come. We'll use earthing and we'll come to this. Let's come back to this one, this discussion, these two. So this one was having this side negative, this side positive, and so this one will have this side negative and this side positive. Now what do you expect between these two? What do you expect? If I keep this rod nearby, somewhere here, nearby, no touching, no touching. If I keep it nearby, what do you expect between these two balls? This ball will slightly be attracted to it, but then these two also attract each other, and you see they hit each other. Something that you can try out yourself at your home. Very easy to do it. Just you have to hang it with a thread. I have pasted it with those. See, I folded that ball in a metal ball and then connected the thread with a that Fevicol. And because that Fevicol was wet and I had to get ready for the class, so I put a small piece of paper to hold that thread. And it's something that you can do. Try doing it. And now we come to this issue that we will discuss one thing, that right now, if I know whatever I'm teaching you, this is all in NCERT. So don't think I'm teaching you something beyond NCERT. So just take interest. If we are not able to do numericals today, we'll do it tomorrow. Don't worry about that part. Tomorrow the class will be at the usual this 12:30 wala time, and Sunday we will see. So let's discuss this part. Say they are separated to each other, they have not touched each other. What happens if I remove this rod? If I take this rod away, everything comes back to normal. Whatever it was, it comes back to the normal. Now, the second case, let's touch these two balls. Say when the rod is nearby, let's touch these two balls. So what will be the scenario? Let me increase, say, let me add one paper to it. And let me draw this. So the situation now is that that there is one ball, there is another ball which is touching it, and they are on a stand. Stand will not matter now. And say there is this rod which is positively charged. Conduction, attract. Okay, let's see. So this side is negative, this side is positive, because now they are touching. Hai? Now if I remove this rod now, what do you expect? There would be nothing. When I remove this rod, all this plus minus will travel and they will cancel out each other. Nothing will happen. But what if, while this rod is in the neighborhood, if I separate them out, first I separate them out and then I remove this rod, now what do you expect? Because I have separated, so this ball will have negative charges over it, this ball will have positive charge over it, and you have got no back to normal now. Now you have got balls. Now you remove that rod. This rod, now you take it away. Now you take it away. You will have one rod, one ball which is negatively charged, one ball which is positively charged. The similar kind of discussion can be taken over to a single ball, but then there you have to do something else. Let me do that discussion also with you. So you have a single ball and you bring near to it one rod which is positively charged. I think I have picked up a wrong pen. Okay, so you expect this to be negative here and this to be positive here, and say this was hanging with a non-conducting thread. Now suppose you connect it to earth, and you know now what is the meaning of earthing. You know now that what is the meaning of earthing. What I did right in the beginning to ensure that there is no residual charge on it, that is what is called earthing. So what do you expect? When you earth, you expect that this thing will go off and you have a negative charge here. Now what will happen if I remove this rod? If I remove this rod, there is a negative charge. It will attract positive charge from the ground and everything becomes usual, what it was earlier. But if you remove this wire first, this connecting wire first, and now you remove the rod, you cut off this connection first, and then you remove this rod, then this negative charge will distribute itself over this metal ball and you will have a negatively charged ball. So let me take you to your NCERT. So this part we have covered up 1.3. 1.2 we covered yesterday. All these activities and we covered it up yesterday. And in 1.4, this is what we have covered just now. This is 1.4, charging by induction. There is a charging by conduction also, where you touch. if you have a, say, positively charged metal rod, you touch it with the, say, ball, that positive charge goes there. That is charging by conduction. You touch, actually you touch. Now, this is given in this page that you are seeing, that is given as such in that course that I have mentioned on anytimeteacher.com. Oh, this is exactly from there, exactly from there. So this we have done. And these are the questions which are, this is NCERT solved example 1.1. As I told you, this course is NCERT based, and every question of NCERT, I'll be doing it in the class. So if you are following me for as long as you are able to follow me, one thing you will be sure of, that your NCERT has been done word to word. And not only done, we have done activities on that, and I have tried my best, and you have tried your best, that you understand every word of it. Every word of it. So this is NCERT solved example 1.1. How can you charge a metal sphere positively without touching it? Without touching it means you don't touch it with a rod. How can you do that? Don't say you bring a negatively charged rod near to it and then you remove it. You know, when you remove it, it will be neutral. It will not be, but it is in nucleus and only electrons move, right? Shreya Arora, not exactly. Metals, or say conductors, they have freely moving electrons throughout that piece. So, incidentally, let's say this is not a conductor. No? Now, let's say this is made up of uh, any non-conducting substance. The nucleus is positive, outside there are electrons, and those electrons are tightly fixed to each atom. So every atom having nucleus, positive nucleus, and electrons around it, overall neutral, they are packed in a way that their electrons remain with them. Like a nuclear family, everybody with their family, they are happy. But if this piece is a metal piece, then the outer electrons of each atom, they are not very tightly bound to their nucleus, to their parents. And those kids are wild kids, they keep running over throughout the it. And there is a lot, if it is a metal piece, I'm saying if it is a metal piece, I'm having metal piece, but then that's not worth showing. So if it is a conductor, every atom has contributed few electrons which are moving in that piece freely. And these freely moving electrons, this is what gives that conductor that special feature that you call it a conductor. Because these electrons, they can take up energy, move around, all those kind of things, they can happen. Earth a material and bring it closer on the metal. Okay, yeah, you are giving the answers. By the way, Gemini Creations, all of you people, try and see if you can give your own name to yourself. Okay, what is the difference if the rod is removed while the ball is in contact with the earth? Compared when the ball is not in contact with the earth, we have discussed this part. If the ball remains in touch with the earth, then when you remove that rod, everything will be neutral. But if you remove the earthing first and then you remove the ball, there is a net charge which stays on that metal ball. And then there is another question there. How will you charge the ball negatively? You do the opposite. You bring a positively charged rod near to it. There are a few questions which are there in the text, which is there in the course on anytimeteacher.com. I hope this much. Arpita, you have a very good name. So Gemini Creations, let's see. I won't force you. I was just joking. Actually, I was just joking because your parents gave a very beautiful name to you. Might be you have your own reasons to give it Gemini Creations. That's okay. That's okay. But then do allow me also to call you Gemini Creations, because remembering that you are Arpita is not so much easy for me. Okay, so because I said I'll restrict the class to around 40 minutes, but then if you allow me, quickly I'll give you one or two numericals which are based on, we will do this 1.5, but then there are some simple numericals in 1.5, NCERT 1.5. There are a few simple numericals. For example, when you say this has been charged, that has been charged, the ball has been charged, how many electrons have moved. So basically what you need to know is how much charge one electron carries. See, what moves is an electron. I told you that it is just a mere coincidence that what moves turns out was in the party of negative one. They didn't plan it that way. So how much charge one electron carries? Now that's where one term comes, quantization, that it carries a set amount of charge. It is not that a fatter electron, a thin electron, a kamzor electron, a powerful electron, and they carry different charges. No, it is not so. Quantization means that every electron carries a set amount of charge, which is 1.6 into 10 raised power minus 19 coulomb. So let's take some questions. NCERT solved example 1.2. Just now we saw 1.1. If 10 raised power 9 electrons move out of a body to another body every second, it means in 1 second these many electrons have moved. Each electron has a charge of 1.6 into 10 raised power minus 19. Then how much time is required to get a total charge of 1 coulomb on the other body? So let's try this question. 10 raised power 9 electrons. So in 1 second, how much charge it is? Let's try it out here. And in case, say, this will be the last question that we will do, and we will carry on from here tomorrow. So 10 raised power 9 electrons. 10 raised power 9 electrons. Oh, 10 raised power 9 electrons, each electron having this much of charge. This is in 1 second. This is in 1 second. So this much charge takes 1 second. So the question is, 1 coulomb will come in how many seconds? This is the question. Remember that if 15 rupees you get 10 bananas, then in 30 rupees or in 45 rupees, how many bananas will you get? That kind of question. This much of charge in 1 second. So this much of charge in how many seconds? I'm quite sure you will be able to do that. We have done 2 solved examples. We have done 1 activity. We have seen this charging by induction, charging by conduction through some activities. We will continue from here. Tomorrow onwards, the class will be at 12:30, and I will keep it short so that your interest, you don't get tired, because I know you are attending other classes also. So see you again tomorrow. If you want to continue the discussion, you can do so in Telegram group. You can continue to do that. Even I have given my own personal number. You can send me WhatsApp message. So see you tomorrow at 12:30. Thank you so much. Thank you for being in the class.